This is lesson 6-4, parallel lines and proportional parts. So the goal is I can use parts formed by parallel lines to determine the lengths of segments in similar triangles. So I think you just need to use common sense when you look at these particular drawings and make good proportions based on what you see there. That's the whole key. So we have the parallel lines in this drawing. So if you look at B, E, and C, D, they've got this arrowhead on there, which tells me that they're parallel. And therefore, what we have is we have similar triangles just by angle itself. So remember, if you have a parallel lines cut by a transversal, there's those corresponding angles that are congruent. So here are two different pairs of corresponding angles that are congruent. So these are similar by angle. We learned last lesson. So we can just make good proportions, all right, like this. So if I wanted to figure out x, all right, so I'm going to use a side of the triangle that I know. Let's see here. Yeah, so I'm going to use 3 and x to write some proportions here. So in the small triangle, I'm going to put 3 on top and then x on top from the small triangle. And then from the large triangle, so when I say small triangle, I just looked at this triangle here. And I said, well, let's use 3 and x, because in a proportion, you have to use a value you know to find a value you don't know. So I couldn't use y and x in the same proportion. That wouldn't make any sense, right? Because then I wouldn't be able to solve it. I'd have two variables in there. But now in the larger triangle, we've got 3 corresponding to 5. Sorry about that. My pen went wacko on me. And then x corresponds to that bottom. So the bottom side, or this right-hand side of the triangle. So we've got a right-hand side of the small triangle and the right-hand side of the large triangle is 3.5. And so that's a good proportion. So this side 3 corresponds to this side 5, and then x corresponds to 3.5. And you cross multiply. 5x equals 3 times 3.5. Then we're going to divide that by 5. And we're going to get 2.1. So we get 10.5 for that. Divide 5. And x is 2.1. And that says find BE, which we just did. So this is BE. Let's just back up. This is BE. Okay. And then we need to find AD, notice it says. So to find AD, we need to find Y. So this time, let's set up a proportion with the small triangle again, but this time we're going to put 3 and Y on top there, right? And so what does 3 correspond to? It corresponds to 5. And then what does Y correspond to? Well, Y corresponds to this entire side. So what are we going to call that side? Well, it's made up of Y and 3, so this is like between this, right? I got small and a small, and E is between, so Y plus 3 would make the expression for the entire side. And so this is going to be Y plus 3. So I'm going to do 3 times Y, which is 3Y, and then 3 times 3, which is 9. And 5 times Y is the cross product there. Now I'll subtract 3Y from both sides. And that gives me 9 equals 2Y, and then Y is 4.5. But they want AD, so AD would require that I take 4.5 and add 3 and get 7.5. Okay? There you go. That's a good example. It's a good one to start out with there, right? So here, you try one. So just look at the drawing and just, first of all, you got to decide whether they're similar figures or not. Well, you've got parallel lines, so once again, we've got these 2 pairs of corresponding angles, so yes, they are similar, right? And then you just need to make a good proportion to find the value of x. So, we really, just a smart proportion could be this. It could just be 5 over x and 6 over 3 3/5. That's a good proportion. I mean, it's just staring you in the face right there, see? We got our 5 over x, and we got our 6 over 3 3/5. So we just need to do a good math here. 6 times x is 6x. Well, 5 times 3 3/5. Do you want to take 3/5 and turn it into a decimal? So that's 3.6 then. So 5 times 3.6 is 18. And then I'm dividing by 6, and x has a value of 3. So now answer the questions. What's QP? Well, that's 3, because that's the value of x. What's MP? Well, MP is the value of 3 plus 5, or 8. Okay? Give this one a try. Stop the video and try it and come back. So ST is parallel to RQ, so once again, we have this corresponding pairs of angles in this drawing. So yes, they're similar triangles. PT is 7.5, so I'm going to start labeling this stuff on the drawing. TQ is 3. SR is 2.5. And they say find PS. Well, again, this is a perfect proportion. It's just staring at you in the face. X over 2.5 is equal to 7.5 over 3. So these parallel lines break off proportionate segments. So the parallel lines split PR and PQ proportionally, so that I don't need to use entire side lengths. I can just use pieces of sides, and I get the same answers. So that's 3x, 2.5 times 7.5. It's going to be 18.75. And I'm going to divide by 3. And I believe that's 6.25 for x. And that's what they wanted, which is PS. Okay. So the triangle mid-segment theorem. Well, the mid-segment is parallel to one side of the triangle. So here's my parallel to one side of the triangle, right? When I scribble it, it thinks I want to erase. There we go. So it's parallel to one side, and its length is half the length of 1/2 the length of that side. So let's read this again. A mid-segment of a triangle is parallel to one side of a triangle. Oh, okay, yeah. So then it's the mid-segment's length is half of this. So XY is half of CB. That's what it's saying. So its length, meaning the mid-segment, is half the length of that side, being the one it's parallel to. Okay, so like if this side were 10, then this would be 5. Okay? So right here, if X and Y are midpoints, and XY is parallel to BC, XY is half of BC. So BC is 10, then XY would be half, or 5. Okay? It's only because these are midpoints. X and Y are midpoints. So what you've done is you've basically created a triangle that is just half the size of the larger one by making that mid-segment. So the small triangle is half the size of the large. Okay? Double any side and you get the side length of the large triangle. So let's see how this works. In the figure, XY and XZ are mid-segments, good, of triangle RST. What's the length of XZ? Well, these are midpoints. And so what's the side that XZ is parallel to but RT, right? So XZ is parallel to RT, so XZ is half of RT. So it's 13 divided by 2, or 6.5. ST, right, is a large side of the triangle, and it's parallel to XY, right, which is the mid-segment. So that means XY is half of ST. Well, XY is 7, so ST is 7 times 2. Or, trying to make my group symbol there. There we go. This would be 14. And what's the measure of angle RYX? Well, these are parallel, and I see a capital Z there. So here's that capital Z right here. So RYX is 124 also. Okay, alternate interior angles right there. This pair of angles right here. This one and this one. Okay? Bringing back some old stuff, right? Stop the video and give this one a try. Okay. What's DE? Well, DE is a mid-segment because these tell me E is a midpoint and these tell me D is a midpoint. So it is a mid-segment and it's parallel to AC. So DE is half of 15 or 7.5. What's DB? Okay, well, what's AB parallel to? AB is parallel to 9.2, and I know that those are 9.2 is a mid-segment too because these two are congruent, and these two are congruent. So those are that F and E are midpoints. It's parallel to, so FE is parallel to AB, so FE is half of AB. Well, in other words, AB is twice FE. So if I take 9.2 times 2, I'm going to get 18.4, and that's the length of AB, but we want DB. Well, it's just half because those are midpoints. That's a midpoint. So DB is 9.2. Angle FED. We're looking for that zigzag. Here it is. Trace the zigzag. So then here's my alternate interior pair of angles. I'll do them in red. Here and here. And they're asking for angle FED. Well, that's this angle right here. So 82 degrees. Okay. It doesn't look like much like an 8, does it? 82 degrees. Okay. Parts of parallel lines. If 3 or more parallel lines intersect 2 transversals, then they cut them proportionally. If 3 or more parallel lines cut off congruent segments on one transversal, they do so for every transversal. So these might be in the ratio of 2 to 1, and these would be like 4 to 2. So it marks off proportional segments on both lines. Okay? Or we're saying if this pair of segments is congruent, then this pair of segments has to be congruent as well. Okay? So, for example, these marks tell me those are congruent. Therefore, 6x minus 5 is equal to 4x plus 3, and 3y plus 8 is equal to 5y minus 7. So, subtract 4x and I get 2x. Add 5 and I get 8. Divide by 2 and I get 4 for x. On this one, I'm going to subtract 3y from 5y, giving me 2y, and then I'm going to add 7 to 8 and give me 15, and divide by 2, and I get 7.5 for y. Okay? You give this one a try. Stop the video and turn it back on when you're done. So the 8s here tell me that these 2 segments are congruent, which means these 2 are going to be congruent then. So if I mark off congruent segments on one line, it marks off congruent segments on the other. So I'm going to do 7x minus 2 is equal to 4x plus 3. Subtract 4x from 7x, and that's 3x. Add 2 to 3 and get 5. Divide. And x is 5/3, or 1 2/3. Okay. Give this one a try there. I would suggest you label the drawing. SR is 5. PT is 15. Find TQ. Well, this is a perfect proportion setup for you. Right there it is. 12.5 over 5 is equal to 15 over x. So cross multiply 12.5x and 75. And x has a value of 6. But they say find TQ. Well, x is TQ. So there it is. All right, so you'll find more questions like that in IXL M12.